Hello and welcome to this video on the order of operations. We're going to be talking about simplifying math expressions using the order of operations, which is often referred to with the mnemonic device of Pemdas. I'll get into that in a moment. If you're here, hopefully you found your way to this video from my class if you're one of my students, because I pointed you here and say you're still struggling with this. And we need to drill down and talk about the parts you're getting wrong. You're probably getting lots of it right, but in the end, you make one mistake on the way when you're simplifying a large expression and it's not correct. It's an important skill to be done with accuracy and precision. You have to take responsibility for getting it right, not just getting it done. So in this video, hopefully I'm going to change your perception around certain things that you've done over the years and say, oh, I thought the order of operations, the way I learned it, meant to do this, but it really means to do something else. Okay, now a couple of things that are pieces of advice. Number one, don't take shortcuts. Okay, if you're taking shortcuts and getting wrong answers, it's not a good time to be taking shortcuts. The one thing I could say is try to be rigid, okay, as you start doing this. Try and be structured, try and be disciplined, okay? And then let the shortcuts come to you naturally after many instances of practice and say, oh, I see that I could have done this and arrived at the same spot, okay? But the one thing with this is the more that you adhere to this at a strict level, the more you have an opportunity to get the correct answer. So what's the recipe is try to continue and be very strict about what you're doing and be mindful of finding shortcuts as you're doing that, and don't take those shortcuts until you really have a trust in them. Next piece of advice is the order of operations is used predominantly on expressions that have no variables. Okay, just pull one up for a second as I continue to sew on this sort of rant here. You notice there are no variables in these expressions. Well, if it has no variables, you should be able to simplify it on your calculator and get the correct answer. Well, that brings up the age-old question of, well, why learn to do it at all if you could just do it on your calculator? Well, I'm not going to get into that here and waste time, but you do need to be able to do it without your calculator and just your calculator assisting you. The short answer is it is about developing good reading and writing skills with math. And if you're going to go to high levels in math, you are required to do those two things, read and write in mathematics at an incredibly high level. Okay? So shortcuts will lead to long delays. You should really avoid taking them in terms of your reading and writing development. Okay, so let me go back here and I'll talk about some things you've probably heard in terms of the order of operations. Okay, just sorry, 1 second to take a look at this problem here. You notice we have multiple operations here. There's things being raised to exponents, there's subtract, there's multiplication. I want you to also note that there's parentheses in a variety of places in this first problem too. Similarly here, you have multiple operations, and it begs the question there with fractions inside of fractions, oh my gosh, should I do something else? Well, no, you're still going to do the order of operations. I can't stress this enough. The order of operations is a universal approach. Every mathematician uses it and respects it at a level of it has to be done this way and in this order when doing these problems. Again, you're simplifying, not solving. You're not finding a missing letter. Okay? You're telling me the simplest way to say this one number. Okay? So coming back here where it says simplifying using the order of operations, you've probably heard that talks about parentheses, exponents, multiplication and division, addition and subtraction. Okay, so with that, that can be a little bit confusing. This idea of parentheses can be very confusing, and I'll just pull up this example here in a second and sort of point to it. If you notice here, there's a set of parentheses here, okay, and a set of parentheses here, and a set of parentheses inside it here. I'm going to put a little focus on that for a second. This set of parentheses here that I've underlined is a little different than how we read this set of parentheses here. And this can be very confusing, okay? And again, I'm going to set this outer set that comes second in red there, okay? So what are the two red things I have in common? Red things I've underlined have in common? They're parentheses denoting groups, okay? And the green one is parentheses denoting multiplication. And actually, though, if you notice here, This is actually a situation where this is multiplication of a group. So that can be a little bit confusing because you're sitting there saying, well, parentheses used for multiplication, but multiplication also comes later. So is it do parentheses now or do parentheses later when they mean multiply? Well, stop thinking about parentheses, and it's really something that can screw you up, and start thinking about the idea of groups, okay? So parentheses means groups or quantities. More importantly, you want to focus on if there's parentheses in a problem, you're being asked to simplify what's inside it. Followed by simplifying exponents, and then multiplication slash division. Well, when you heard me read that, didn't I say multiplication first, then division? Well, it kind of makes you think multiplication comes before division. Similarly, when I say addition slash subtraction, you hear addition first. Well, it makes you think that addition comes before subtraction. These aren't actually true, which kind of stinks because we give you this shortcut and tell you that you sort of are armed with all the stuff you need of just PEMDAS, okay? And M is before D and A is before S because that's the only way you can really say it. Well, I reflected on this some years ago and thought maybe I could come up with a different sort of visual organizer for Pemdas, and I was taking a flash class, and I kind of made this thing, which is kind of cool, I think. Now, if you notice, this doesn't say parentheses as much as it starts up here in the red. The colors tend to match pretty well, except at the bottom where the black and green are interchanged, okay? But what I'm trying to show you here is you're trying to focus on the stuff inside the parentheses. And if there's multiple operations inside the parentheses, you treat them with PEMDAS again. So that's the idea of that. And then here, nothing too fancy, that it says exponents, but it gives you an idea what an exponent is. It's the little number up there to the right of a number, which means raised to the power of that. And I think this is the idea that I'm trying to create for you here. Okay? The idea that multiplication and division, if you notice these blinking eyes, it's not always multiplication first. It's multiplication or division, and I put them inside of eyeballs that kind of give this effect. It's whichever one you see first when you're reading it. So if you're reading something from left to right and see divide first, you do divide. If you see multiply first, you do multiply. Similarly for add and subtract. If you notice down here in the lower eyeballs, you have a plus sign and a minus sign, but when they blink, they change positions. What am I trying to tell you there? Well, when you're talking about add and subtract, it's not do add before subtract, it's do them in the order that you see them from left to right. Okay? So this is kind of like just a little thing I made a couple years ago that I think gave people some pause to think. Because if you're saying it's PEMDAS is going to help you do PEMDAS, well, you're just saying that M came before D, and that's multiplication before division, but it's not really true. Similarly, you said A before S when you say PEMDAS, and A doesn't really come before S. So it's like we tell you here, use this, it's going to help, but I think it actually can hurt a little if you don't look at it correctly. Okay, so let's get into these examples here, and I'll try and color code them against the idea of PEMDAS, okay? And we will take a look at simplifying these expressions. Number one, I'll read it, and I'll say the opposite of the quantity, 3 minus 5 to the power of 2, minus 2 times the quantity, 7 minus 2 times 6. Okay? So as I go through this idea of PEMDAS again, I'll just bring this organizer over here temporarily so we can refer to it. It's a small version of it, but you get the idea. I read the problem, and I notice I've got parentheses about, but I don't think parentheses, I think of groups. Well, there's a group here, and there's a group here. Okay? And then I also notice that inside this right group, there's two operations. There is subtraction, and there is multiplication. Okay? So, referring to the top part of this icon here where it says if you have parentheses where that have lots of operations in it, how should you handle it? Well, handle it in doing it in PEMDAS order again. So you would sit there and say, well, what is going to come first between minus and times. It's going to be the times. So I'll just very strictly, if I'm just doing times inside of parentheses here, I'll just copy from left to right the part I'm not doing and wait patiently until I get to the part that I am. Now, if you notice here, I'm actually going to do negative 2 times 6 and associate the sign with it and get negative 12. Well, if you notice, that was me acting inside a set of parentheses. And I'm going to do it again because I've got still this group of 3 minus 5 and still this group of 7 minus 12. So outside of it, I'm still going to write the parts that I'm not doing. So it's the opposite of the quantity of 3 minus 5, which is negative 2, squared, continuing to copy, minus 2, times 7 minus 12, whose answer is negative 5. Okay? So from there, I look for any exponents, and I do have them here in blue. Okay, I'm using these boxes when I write. They're kind of a help. If you can make them quickly, it's great. So outside this box is the negative sign. Negative 2 squared will be positive 4. Then I'm continuing to copy the rest of the problem, doing one step at a time. I could have known that that answer at 2 times negative 5 was coming up, but I wasn't doing that. I was doing exponents. Okay? So now I look here for multiplication and division, and I notice that I have it here. And again, I hope you notice that I actually associated in the negative sign, which was a minus sign in the problem, but I kind of grabbed it up here as I'm doing it. That's a good writing strategy. So I pull down my negative 4, and then I see that negative 2 times negative 5 is plus 10. And it's good for my writing because now if you notice, instead of writing minus negative 10, it gave me the opportunity to just write the 1 sign. So then I have 10 minus 4, or negative 4 plus 10, depending on the order you want to read it, which is 6. Now, to check this, the only thing I need to do is go on my calculator and type the original problem, which I will do by saying the opposite of the quantity, 3 minus 5 squared, minus 2 times the quantity, 7 minus 2 times 6, which is in fact 6, so I know it's correct. Well, why'd I do all that work if I knew I could just go to my calculator? Again, this is about the basics in terms of reading and writing, and you cannot mitigate your opinion of thinking of how important it is. You cannot sit there and say, oh, it's not that important, I'll just use my calculator. It's a fast track to nowhere in mathematics. I'm a firm believer in that. Okay, so now looking at this next problem, we see that we've got 2/5 minus 3 times negative 2/5 all over 4 minus 2/7 times 7 squared. Well, this is kind of tricky and challenging, and I've done that on purpose. If you notice here, I've got a numerator and a denominator. Well, the operation that separates a numerator and denominator is division. So my kind of general strategy when I do this is try and get the top down simplified to one number, even if it's a fraction, and then simultaneously work on the bottom and try and get that down to one number, even if it's a fraction, and then do the division in the end. So now as I'm looking through the order of operations, I look for each thing on top and on bottom. And whatever I'm doing on top, I only address to do on bottom, and vice versa. Okay? So I'm looking for parentheses here, and I've got a couple sets, but they're not groups. There's no group inside the parentheses here, no group in here. It's just a singular term. Okay? On top it's negative 2/5, on bottom it's 7. Okay? So there's kind of really no parentheses to do. Okay? And I'll sort of put that in a quote. It's kind of like something I'm going to contradict myself on later when I go to the calculator. Okay? So that moves us over to exponents, which is right here. Just using my extra strict writing technique, I'm just going to copy the top because it has no exponents. Copy the part of the bottom that I'm not doing. And then do 7 squared in blue, which is 49, right? And then this moves me over to multiplication and division. Again, I'm going to do the division in the end, okay? Um, so we take a look here and we realize, again, grabbing up the sign, that's a negative times a negative, and here's a negative times a positive, okay? So okay, and then what do we have here? Copying the parts that I don't have. 2/5 plus 6/5. Well, if you didn't know that, you could go to your calculator and say what? -3 times -2/5, math, enter, enter, is 6/5. Okay. Similarly on bottom, what are we doing? We're copying the 4. And we're saying 2/7 of 49, -2/7 of 49 actually. Okay, is -14. And if you didn't know that, you could sit there and go -2/7 times 49 is -14. Now continuing on, I'm just doing my adds and subtracts on top, and my adds and subtracts on bottom. So that's going to take me to 8/5 over -10. And then from there, now that I've got the numerator and denominator kind of down to one number apiece, it's a great time to go on my calculator. But a little caveat here, the 8/5 should be associated together with a set of parentheses. -10, excuse me, I got two divide signs in there. Okay? And when I get a decimal like that, it's a great time to hit math, enter, enter. And then you see that I get -4/25. Now, back to what I said here about the fact that there's no real groups. Well, there are and there's not. Actually, there are and there are, but I kind of didn't address that here. Okay, we said those parentheses are singular. There's actually sets of parentheses here that are not in the problem. They'll really come from this portion right here. Okay? If you notice that division expands multiple terms and multiple factors, which implicitly makes the entire top a group and the entire bottom a group. Now this is really important because when I go to my calculator, I've got to insert those parentheses. So if you notice, I can really do this whole thing in one shot. And it's going to say what? Left parentheses, 2/5, -3 times -2/5, and that group divided by the entire group of 4 minus 2/7 times 7 squared, and then end that entire group. Okay? So we get -0.16, which as a fraction is -4/25. So I hope that this has given you some ideas of places you could change if you're struggling. Again, be strict. Write methodically. Don't try and do multiple operations per line. Okay? Places that we do this, where we make mistakes, often are places where kids are confusing parentheses as a group with parentheses for a multiplication and or vice versa, and they're kind of making mistakes here, which I understand, because if we're telling you, hey, do parentheses first, it's not every place you see parentheses, but that's what it sounds like. Okay? And when we say, oh, multiplication and division, that sounds like multiply first, right? But it's really whichever one you see first. Again, think of these eyeballs and this blinking little icon I made here. Okay, well, I hope that helps. Use your calculator, check your work. Hold yourself to a level of mastery in this. You will not regret it.